Namaste. I hope you are fine, doing well in your life. So today we are gonna solve the problem LeetCode 75. See the first problem from monotonic stacks. So currently we have solved all the first problems from all the previous topics. So you can check through those questions in the playlist which I have mentioned in the description. So now start with the first problem of monotonic stack. The question is, actually I have already solved this problem earlier. Okay, so I will explain it to you. Fine. The question is daily temperature. Given an array of integer temperatures represent the daily temperatures, return an array answer such that answer is the number of days you have to wait after the ith date to get the warmer temperature. If there is no future day for which this is possible, keep. Okay, I have understood the problem. So let me explain it to you. So what is given is, we have given the list of temperatures, right? Now what we have to do, we have to return the number of days after which we will got a slightly warmer day. So for the I equals to 0, we will got a warmer day at next day. So the answer will become 1 for I equals to 0. For this day we got a warmer day at next day, so answer is 1, means the next day. For this day we will got a warmer day after 4 days, right? So this is first 2, 3 and 4th day, the answer will become 4. For this day we will get after 2 days, so answer will become 2. For this, the next day, so answer is 1. For 72, this is 76, so answer is 1. And for 76 we will never got a warmer day, right? So answer will become 0. And for similarly for 73, answer is 0. So this is the output. This should be the output. So how to solve this, right? How to solve this? So I have already I always ask you to do two simple things, right? So first, give your focus on the details, what is given, what is needed, what all things are there. So also have a look on the constraints. For this will give you the better clarity on the time complexities, right? So okay, so this is the detail, this is the given, and this is the this is what we have to return. So we have already discussed those things. Now the second most important thing is, if you can't think about the optimized approach, right? So you have to start with the native approach first. Native approach first, right? So the native approach is, we need to find the next warmer day, right? So we will start with the we can use 2-pointer approach. We will start with the 73 and we will iterate through all the array and we will find the next warmer day. So this will require 2-pointer approach. So this will require time complexity of n square, right? So because we will need 2 nested loop, space complexity of nothing, n, right? So this is the native approach. So let me explain to you how to. Okay, well, there's no need to explain the native approach because this is the most basic thing we can do for this question. Now how to optimize this, right? How to optimize this? So can we do something that in which, like, we don't need to iterate again and again and again? Can we store the data somewhere? So yes, we can use stacks, stacks. I have already explained what the stacks are in today's problem of the day. You can check that video also. I have uploaded that video on a different playlist for today's problem of the day, right? So how to use stack, right? So let me give a visualization for that, right? Okay, so what we can do, so let's say this is the input. So first we will put the first character we'll put the value and index, right? IDX index in this stack. Okay, If you think this video is very slow, you can see in the 1.5 or 1.25 speed, right? So okay, so we'll put 73 and value index is not 0, right? Then for this 74, right, we will check if the topmost value of this stack is smaller than 74 or not. So if yes, we will initiate a answer array which initially contains zeros, right? Okay, so if yes, that if the topmost element is smaller than this, right, current element is 74, so the topmost element is 73, so this is smaller, so we will then take this index, so this is 0th index, and we will replace the answer with this I minus index. So I is 1, index is 0, so this will replace with 1. That means we will get the warmer day 1 day after this 0 index. This means we will get a warmer day at first day. This is the meaning of this I, right? Then we will pop this out and we will put 74 with index 1, right? This is 74, don't get confused, guys. This is 74. My writing is too bad with this mouse pad. Then with 75 we'll again do this same. The 75 is greater than 74, so we will pop out 74. We will upload 75 here. 75 with 2, and we will make this one. So the first index at answer, we will replace it with the 2 minus 1, which is 1, right? At 71, at I is equals to 3, right? We can see that 71 is not greater than 75, so we will put 71 here with I is equals to 3. Then again 69, this 71 is done. Then 69, so 69 will be put it here, 69 will be appended here. 69 is not greater than 71, so 69 with I is equals to 4. Then we will get a 72, right? 72 is at I is equals to 5. So 69 is smaller than 72, so we will pop this out. We will see that the 4, so we will this is the 4th index, 0, 1, 2, 2, 3 and 4. So we will replace this with 5 minus 4, which is 1, so again, so we will again check that is if this topmost element is smaller than 72. So yes, 71 is smaller than 72, so we will pop this out. We will replace this third index, right? Third index with 5 minus 3, so this will be replaced with 3. So this is 5 minus 3 means 2. This will be replaced with 2, and then we'll check that 75 is greater than 72, so we will we cannot pop 75 out, so we will append 72 with index 5 right here. Okay, now we have 76, so 76 can remove this 72 because 76 has greater 76 is bigger than 72, so we will pop this out, and the fifth index in answer will be replaced with 6 minus 5, which is 1. Then we can check that 75 is also smaller than 76, so we will remove this out, and we will replace the second index in answer with 6 minus 2, which is 4, and then we will append 76 and we will append 73, right? So this is the solution, which is 1142110. So this is the final solution. So this is how we are gonna solve this problem. I hope you understand this approach. Okay, what is this? Okay, I hope you understand this approach, right? So let's code this out. We are making a stack using DQ. DQ is nothing but a queue. So the main important difference between queue, DQ and stack is, so this is a stack, right? in which you can only put from append from the top and remove from the top. So this is least in last in first out. So the element which is inserted in the last get out in the first place, right? So the topmost element will get popped, right? So this is stack. Q is first in first out type of a data structure. So Q worked on first in first out. So the element which inserted first will get out first, right? So this is Q means a line type of thing in which whole element get closer to the exit point. So this is Q, right? DQ has both the properties of Q and stack. DQ means you can either append from starting, you can either append from end, you can either pop out from the start, you can either pop out from the end. So all these property contained by the DQ. So we can use DQ for making a stack, right? What we can do, we can close the second gate of the queue. We can only append from first, and we can only pop out from the first. So this will make DQ a stack, work like a stack, or I can say. Okay, so we are making a DQ. We are making a stack using DQ. We are initiating the answer array. We are iterating through the temperatures. We are checking if the stack has length greater than 0, and if yes, we are checking the topmost elements with x is the value and y is the index. If x is smaller than the temperature of I, so what we can do, answer y will be I minus y, and we will pop out the topmost element from the stack, and we will continue this operation. And if this is not the case, we will break this while loop and we will check for the next temperature. We will append the temperature comma the index in the stack after this while loop, and then we will return the answer. So this is the code of our approach, right? So we will submit this. So yes, this is getting passed. So that's all, guys, in this video. I hope you understand my approach. I hope you understand how to use stack, and most important thing, how to optimize the native approach, how to think of native approach and then optimize it to most optimized way, right? This is a part of my series in which I will solve all the problems from LeetCode 75. LeetCode 75 is a set of problems which is the most important problems for cracking any interview. These are some standard problems from every topic. So we will solve these problems in our video series. I have also started another video series in which we will solve LeetCode daily problem. I will attach the link for that playlist also. You can go through those videos also, and if you want, you can share those videos with your friends if they are also practicing the LeetCode or DSA. Other than that, we will also start another video series in which we will discuss some very strong algorithms which is very helpful for solving the problems in very good time complexities. So these algorithms are used in the competitive programming. So we will discuss all these algorithm one by one in another video series. So I suggest you to stay connected with me. Either subscribe my channel, or you can also join my WhatsApp channel. The link I have given in the description box. So you can click on this link and you will be added in the WhatsApp channel. In the WhatsApp channel, we can also discuss different things. Like we can also discuss about a project. We can also start a project which will be very great for our resumes. And we have we can do all other things like solving the doubts and also discussing different things about DSA and all, right? So that's all from my side. Thank you.